Thank you, everybody. Thank you for having me here. I'm Fawzi Mohamed from the Swiss Supercomputing Center, and I want to talk to you about Apertus and trusted computing at CSCS. So the Swiss Supercomputing Center is a unit of the Federal Institute of Technology of ETH Zurich. And our mission is to develop, promote, and provide services for the Swiss research community in high-performance computing and data management, support and foster Swiss innovation and competitiveness, and enable world-class research by pioneering and supporting leading-edge supercomputing and data technologies. Actually, I was just informed that we have now a shorter mission, but the gist is more or less the same. So now machine learning has been around since quite some time, and also neural network since the 50s and so on. But there has been, as everybody here knows, a big change recently, mainly due to training on larger amounts of data and the transformer model. And so this is having now economic and social impact. So suddenly more people, more part of the society is interested. And if we look at it, we see that private US company and China are at the forefront of the technology. And the development of AI needs large storage and processing power. So clearly, in the need to keep open research and Switzerland competitive in this field came up. And this not just to have some kind of sovereignty, but also to be able to influence the decision on these technologies that are being taken by those that develop it. And we think the only way to do that is through collaboration, really to support the open research, because Switzerland alone cannot keep up with these big entities, but we are trying to help open research and then reach something that fulfills this. And such a goal is aligned with our mission. So it also happened that we had a lucky conjunction of things. So in hardware and in knowledge of research. So on hardware, on infrastructure, we regularly jump at the bleeding edge. This has several reasons. Switzerland is small. We want to support really leading research. So we want to be able to do with the newest technologies, and also part of the learning and having this know-how with new technologies, an important part of our goals. So with ALPS, we have an heterogeneous hardware, but in particular, what I will talk about is the grasshoppers that everybody, I think, is now familiar with. But in our jump, we bet on Grasshopper, and it turned out to be a very good choice because the hardware is well suited for AI. And the other part of the equation is having the Swiss AI initiative that was formed mainly by the ETH AI Center and EPFL AI Center, where researcher, leading researcher on this field were present. So basically, what we decided or tried to do is to follow some guiding principle of trust, openness, and collaboration, and try to deliver foundational model that are as open as possible and can be used by the community, and so where we can also profit then of the work of the a larger community. And we can deliver trusted models to also to Switzerland. But bringing up new infrastructure is always challenging. The hardware is a good choice, but it always has its issues when you start out. And also, we had new users coming in, a new user community, and they had new use cases. A lot more using the data as input, large input, and relatively small outputs, whereas normal HPC is small inputs and large outputs. So it's different issues and also new challenges. So to address that, we tried to have a balanced approach with old and new, because we need to deliver a service, and in the end, we want to have successful users and successful result. So Clariden is a big cluster with more than 1,000 node Grasshopper nodes. Bristol is a smaller data preparation cluster where we also have A100 and x86, and we also have a service plane that uses Kubernetes. An important feature in being able to do this has been our software-defined platform, where we have a versatile cluster and versatile vServices, and we can define a different setup for a different community, and so explore and iterate quicker on just on the things that are needed for that community without affecting everybody else. Container-based user environment have been very important and have been presented yesterday by Felipe. These give the flexibility in the user space to the user to quickly adapt to evolving situation, and in AI things change much quicker than we were used to in scientific computing. Firecrest for workflows, Jupyter Notebook, Valdur, a new interface for managing user in more cloud-like approach. But actually, really, apart all the technologies, the people are really a core part. And in that, when you try to do something new, if it's played well, you manage to have others as partner that also try to solve the same problem. And if it goes bad, everybody tries to blame the others. But if it goes well, and it went well, and we managed to do it, we had very good collaboration with HP, with NVIDIA, and with Swiss AI, and the whole CSCS team, in really all trying to solve all the issues that came up and deliver something new. And one of the first fruits of this is Apertus, which is an LLM based an entirely open LLM with all the data, all the training also kept open, so that everybody can see exactly how it was done and can replicate it if they want. You can check at Swiss AI Apertus as I said, fully open, transparent, multi-language language model. That's a first step. This has been trained on non-English languages. It's actually competitive with Llama models. Talking with others for for example, for Tibet language, this guy was telling me that the performance is even better than Llama, than other open languages, open models. But those models are only open weights. You don't know exactly how they are being trained and aligned. And if you want to be able to trust the model, that's an important difference. Clearly, that's just a first step, because we need to do reinforcement learning to have a thinking model based on this. The pre-training was a large effort. Just to visualize something, at the beginning, the training was difficult and unreliable. And this is not just solvable through the part in containerized. This is really issue at the kernel, hardware level. We couldn't scale. This is the throughput per GPU. But what is not visible, we were using much less GPUs at the beginning because we couldn't scale. And we had issues all over the place. We had to patch kernel drivers, patch the kernel, patch the drivers, the unified memory. Kernel is nice of Grasshopper, but the kernel, for example, tries to use it to allocate a file cache on the GPU memory. And this is not something that you necessarily want. And the freeing up the memory that was allocated didn't work initially, so it was broken. We had issues for find way to pin to the correct NUMA domain, and not just in the user space, also in the kernel, telling the kernel don't use the GPU memory. Patch and upgrade communication libraries. We had issues with Nickel, with libfabric, GDR copy, implementation with bugs, all kind of things that came up and made the things challenging. And it has been really an effort of the whole center at all level and also our partners to be able to deliver this. And also I/O, how to properly use Lustre, striping, these kind of things. So it's not just Apertus, as I said, we have also other things. For example, trying to have a foundational model for climate or medical data. And for that, security is an important aspect. AI security has always been important. If you don't care about security, your system will not work for a long time without issues. But in general, in HPC, there is less interest on trying, less economic interest and less effort to subvert the tool chain or the whole things to inject things that are malicious. In ML, it's more present. It's an attractive target, and you have to care more. And then other trusted computing, because trusted computing here was about having a model that you can trust, which is also something. But before coming here, I was thinking of trusted computing something else, so which is also trusted computing, but it's really the trusted research environment. So when you have a data that you don't want to leak, you have personal data. There we are starting. We have the first collaboration with 3. What we aim to is connecting to a trusted environment with our infrastructure, let them use it without compromising things. We don't aim at creating a fully trusted environment. Confidential data handling is something where we also have work to do. HPC is much simpler from that part. You have to care generally, but the data is generally data that is not so sensitive. And inference service. We are looking at providing inference service, especially if one wants to have inference for his own data in a or a model that they can trust. So that's it. CSCS always had and still has the implicit goal of supporting an open society in Switzerland. Trusted computing is something that we want to support in the ML platform. Support for open science is key. Apertus is a first step in that direction. And infrastructure to safely use AI is another cornerstone. So the 3 project and so on, where we are not yet there really as a product, but it's something we want to expand on, an inference service, and collaboration is the way that we want to stay competitive. So contact us if you are interested. That's it.
Thank you, Fawzi. James.
Hi, thanks. Really interesting talk. Language model with genuine open source, not just open weights, that you've created is a tremendous step forward. But I've been trying to say for a while that, getting to the guess the next word engine is only the beginning of an open AI ecosystem. Can you tell us more about the plans for doing fine-tuning for chat, building alignment systems, and those kind of pieces that happen on top of the base LLM?
Yeah, it's effort that is ongoing. We also really want to, one reason to make it open is that maybe also other have other ideas and can also contribute to that. So that will be totally welcome. But we are working on reinforcement learning to have a reasoning model. Multimodality is showing good progress because currently it's just text, but you definitely if you want to give it to someone and say use this instead of ChatGPT, there are still places where definitely it's not yet there at the same level. And multimodality is one of those. Then we plan to retrain, and we welcome data, or if someone has comments on the data that we have used or new data, because this was actually something that has been required when we proposed this. Also the commission said yes, but then you have to follow up at least because you cannot say it's open and the data is this, and then if something comes up, you cannot fix the data or you cannot do anything. So there will be retraining on data, and we plan to try to react to what gets reported to us on what can be improved or new data that can be used.
Any other questions? Okay, thank you, Fawzi.